Hi and welcome to video 2 of 2 videos for section 7.2. In this section we're just going to expand on an idea that we've already looked at. If you recall, when we had, for example, a problem like sine of cosine inverse of whatever, 3/5. With this kind of problem, this was a few sections ago, what did we do? We said this thing equals theta. And we say theta is this whole thing. We multiply both sides by cosine. Then we rewrite this as sine of theta. We make a triangle so that we can figure out what these values are. So hopefully you guys recall that. We're going to do the same idea if the expression is a little more complicated. We're going to use substitution and we're going to build triangles. So the kind of example we're going to look at, and I'll tell you now, this will be on your second exam. This will be on your third exam. This is very likely going to be on the final exam. So the example says we want to write, and this is the way it'll be worded, sine of cosine inverse of x plus tangent inverse of y as an expression in x and y. What this problem is saying is that when I get a final answer and I draw a box around my final answer, I don't want any trig functions in there. It should only have some combination of x's and y's, maybe numbers, maybe square roots, things like that, but no sine, no cosine, no tangent, no trig function of any sort, just x's and y's. So what we're going to do here, so let me erase this bottom line so I can get to the top that I'm going to be working with. So before we had what? Something like this. Sine of cosine inverse of x. Now we have this extra piece. All we're going to do is say that this first part is equal to, let's call it theta. And this second part, we have to call it something different, so let's call it phi. I'm going to use the same process as before. I'm going to build the triangle and put the dimensions on the triangle. The only thing now is that I have to do it twice. So let's first just look at this first piece. We have what? We have theta is equal to cosine inverse of x. If I want to get rid of this cosine inverse function, what do I have to do? I have to multiply both sides by the cosine function. So I get what? I get cosine of theta is equal to, these guys essentially cancel out, and I get x. Or if I want to write this as x over 1. Why would I do this? Well, we'll see when we start building the triangle. So now that I have that, I can build my triangle. If I put my theta down here in the lower left corner, cosine of theta is x over 1. So cosine is what? Cosine is adjacent over hypotenuse. So that means my x is going to go here on the bottom leg, and the hypotenuse is 1. If I want this side of the triangle, because it's a right triangle, what can I do? I can do Pythagorean theorem, and if I do that, I get 1 minus x squared. So again, I just do a squared plus b squared is c squared. This is the side I'm trying to find, and when I use Pythagorean theorem, I get that this side is a square root of 1 minus x squared. That's one triangle for this first part. Let's do the same thing for the second. So now I have phi is equal to tangent inverse of y. So if I take the tangent function of both sides, I get tangent of phi is equal to y, or again, I'm going to set this up as y over 1. Now when I build my triangle, if my phi, not theta, if my phi is down here, tangent is what? Tangent is opposite over adjacent. Opposite over adjacent. So y on the tall leg, 1 on the bottom leg. Again, if I want to find out what's the length of this hypotenuse, I need to do what? Pythagorean theorem. So 1 squared plus y squared, and then take the square root of it. So that gives me the hypotenuse is that value. So I've substituted, calling this theta and phi, built my true triangles. Now what I want to do, just as I did when I only had the one function, is rewrite this first one. So what I really want to find out is what? I want to find out sine of theta plus phi. That's really what I'm trying to solve here. So this is what? This is a sine addition formula. And so for sine addition, what do I have? I have sine of theta, cosine of phi, and sine always uses the same symbol, plus or minus, and then it's just the opposite. So sine, since I use theta to start with, it's going to be phi, and cosine of theta. So now I have this original one written in terms of sine and cosines of theta and phi. Why did I do that? Well, now I can actually figure out values for this by going back to these triangles. So first, sine of theta. So that's this triangle over here, the first one. So sine is what? It's opposite over hypotenuse. So it would be square root of 1 minus x squared over 1. Cosine of phi is what? Well, cosine is adjacent over hypotenuse. So it's 1 over square root of 1 plus y squared. So all I did was go back to my triangles using my theta and phi to figure out what's the sine of theta using the first triangle, what's the cosine of phi using the second triangle. And now plus the second part, so sine of phi, that's the second triangle, is opposite over hypotenuse. So y over square root of 1 plus y squared. And then cosine of theta is what? Adjacent over hypotenuse, x over 1. So now at this point I need to simplify. I'm just going to multiply the first two terms, multiply the second two terms, combine them if I can. So with the first two, what I get? If I multiply numerators, I get square root of 1 minus x squared. Denominator is what? Square root of 1 plus y squared. And then I'm going to add to it what's in the numerator, x times y. What's in the denominator, square root of 1 plus y squared. In this case, they have the same denominator, so I'll go one more step and combine them. So because they have the same denominator, I'm going to end up with square root of 1 plus y squared. And in the top, all I can do is add these two. So square root of 1 minus x squared plus x times y. There's no other way to combine them other than just to write them as an addition expression. So this would be my final answer. This is what this kind of problem is looking for. Remember it said, write this in terms of x and y, and that's what we have here. The only thing we have are x and y variables, some ones with some square roots, but that's basically it. So that's what this kind of problem is asking. Again, if you need to go back, rewatch it, make sure you understand how to do this kind of problem. If not, come to my office hours, ask in class, because this problem will show up repeatedly through the remainder of the semester. It's a fairly decent sized problem in terms of the point that it's worth, so I really want to make sure you guys have this idea down. That is the end of video 2 for section 7.2. We'll see you in 7.3.